Hello, my name is Dan Kelly, and I'm going to explain a simple procedure for aggregating lists of ranked items. Imagine that we have some odd number of judges. Here we've got judges 1, 2, and 3, and that their task is to put in order some items, the items A, B, C, D, E. Um, and the rule is that they give a small number if they really like the candidate, whatever it is, a painting, scholarship, whatever it is, and low number. So for example, judge number 1 really likes D, likes C, but not as much as D, and really doesn't like E. So that's the meaning there of these numbers in here. Okay, so I want to show you how you do this, and the text explains it, but I'm just going to show you by just doing it. Let's see what I'm doing here. So I just want to center that. Okay, so the first thing you do is you look at the top 2 rows. What we're going to be doing is always comparing 2 rows. And our task here will be to interchange the rows if the majority of judges think that they're out of order. By out of order, I mean that we want the lower numbers at the top. Okay, so judge number 1 here says those are out of order because judge number 1 wants to put the 4, the A, down here and put the 3 here. Out of order, says judge number 1. Judge number 2 disagrees. In order. Judge number 3, in order. So by majority vote then, happens to be 2 to 1 in this case, but all that matters, majority vote, these things are in order. So that's fine. We don't do anything because they're in order. Now we go to this case, B and C. Judge number 1 says that they are out of order. Judge number 2 says that they're in order. Judge number 3 says that they're out of order. By majority vote, then, those are out of order, so I exchange them. I just exchange C and B. So now I go to B and D. And let's see. This judge says out of order. I want you to switch them. This judge says out of order. I want you to switch them. And this judge, oh, poor old B. All 3 judges say that B is not as good as A, so D. So we interchange them. Now we just look at the second 2. So again, we're only looking at 2 at a time. And each time we do this, the worst judged thing falls down. It falls down if it's not already down. Okay, so this judge says in order. This judge says out of order. This judge says in order. All right. So what we get from this is that E is the least favored of all these options. Least favored. It fell down at the first step, fell down at the second step, or it would have fallen, even if it were at the top, it would have fallen down at the first step, fallen down to the second step, fallen down the third step, finally to be here. What I'm saying then is that we know for sure that this E is the least favored of the whole bunch at the end of this first phase. Now we go to phase 2. And again, things could have been ordered. In this case, they have been reordered. So we have to do it again. So judge 1 says out of order, 2 says in order, and 3 says in order. So we don't have to interchange them. We leave them as they are. Looking at these, judge 1 says out of order. Judge 2 says out of order. I don't even really have to consider judge 3, but anyway, so clearly it's out of order. I interchange. And that judge says in order. This one says out of order, and this says in order. Okay, so it's fine. So what we know at this stage is that E is the, I'll say worst, the least favored candidate. B is the second least favored candidate. And we only have to consider now the top 3. This is the procedure that you do at every phase. At the end of the first phase, we have one at the bottom that need not be considered again. At the end of the second phase, we have one just above the bottom that need not be considered again. And the third phase, and just on and on and on. And you just consider, now we have to consider these 3. So we first look at A and D and move them if we have to. And then we look at whatever's in the second and third and move them if we have to. At the end of that stage, I'm not highlighting here, the bottom 3 will be in order, and then we just have to do one more step, perhaps, and depending on how things are going, and then we'll be done. So you can continue at each phase. You go in pairs of rows, interchanging to put the bottom one at the bottom, And at each phase then, after doing that row by row all the way down to the bottom, the bottom kind of rises up. Think of it as you have mucky water, and the muck, the little sand or whatever it is in the water, gets to the bottom, and it's on the bottom, and then later some more falls to the bottom, and they're sort of sedimenting. The name of the algorithm is a bubble sort, and I guess the idea there would be to think, instead of sand falling, would be to think of bubbles rising. It's the same sort of idea. Anyway, at the end of this procedure, and you could find algorithms for this online, at the end of this procedure, the items will be in order. I'm not saying that they're in order in this list because I haven't finished the procedure. You might want to try that, finishing the procedure, and maybe just randomly putting in some numbers and practicing a little bit. It's really easy to write code for this. I've written code because I used to be chairing a committee that had to look at dozens in this category and had maybe 10 or so judges. And then it becomes a little bit arduous to just look at them one by one and to rank them. So I just wrote some code that does it. In such a small thing where you only have maybe 5 categories and maybe a handful of categories, handful of judges, it's very easy to do by hand.